Alright, now we're going to graph sine and cosine. So I have, first we'll start with sine. Y is equal to the sine of x. When you graph the sine function, the highest it's going to go is 1, the lowest it will go is -1. We will put 4 tick marks. I apologize that my y-axis or x-axis is not terribly straight. We have 2 pi, we have -2 pi. Sine goes through the origin, so the first point you put is through the origin, reaches the maximum, cuts the axis, reaches the minimum, cuts the axis. And its graph, if you graph between -2 pi and 2 pi, it looks like this. So on the left side it really does the same thing. We would say that it has a fundamental period of 2 pi. You might say, what is the fundamental period? What do you mean by that? If you look at it between 0 and 2 pi and you were to pick it up, it's exactly the same graph here. It looks like top hump, bottom hump. If you pick it up, so then it keeps repeating. It's a periodic function, and the cycle just keeps recycling itself every 2 pi units, okay? The domain of our function is all real numbers, or we could say -infinity to infinity, or you might say all real numbers. Its range goes from, the lowest it goes is -1, and the highest it goes to is 1. And it has a fundamental period of 2 pi. When we go to graph cosine function, and by the way, if you were wondering, like, how are we getting these points? How do we know? You'll just consider your unit circle real quickly, like you have 1, 0 here, 0, 1 up here at pi over 2. At pi you have -1, 0, and at 3 pi over 2 you have 0, -1. As you consider it right here at the origin, remember sine is associated with the y-coordinate, so when you're at 0, the coordinate is 0. When you're at pi over 2, the y-coordinate is 1. When you are at pi, because this coordinate here, this is pi, the y-coordinate is 0. When you're at 3 pi over 2, it's -1. Then when you're back at 2 pi, it is 0 again. Same way if you counted negatively. So negative pi over 2, it's -1. At negative pi, it's 0. At negative 3 pi over 2, it's +1. And at -2 pi, it is 0. We're looking at the y-coordinates here, okay? So there we go. There's y equal to sine of x. Now let's go ahead and graph, while we're at it, we're going to go ahead and graph y is equal to the cosine of x. Similarly, related to how we graphed sine, we'll put 4 tick marks. You always put 4 and call the fourth one 2 pi. Then on the left side I put 4 tick marks, -2 pi. Now officially the domain goes from -infinity to infinity, but I guess we'd be graphing a long time if we graph that much. So when I graph this, it does not go through the origin, because if I sketch another quick little circle here, this is 1, 0 if you recall, and at the top it's 0, 1. Over to the left it's -1, 0. At the bottom it's 0, -1. So if you were at 0, remember cosine is associated with the x-coordinate. So if you look at 0, the x-coordinate is 1. So you're going to start up here, and then at pi over 2, the x-coordinate is 0. And at pi, the x-coordinate is -1. And at 3 pi over 2, the x-coordinate is 0. And at 2 pi, the x-coordinate is 1. So when you go to graph this, it starts at the top, and it looks kind of like that. As you go, if you graph the left side here, negative pi over 2 is 0, and at pi it's -1, at negative pi it's -1, at -3 pi over 2 up here the x-coordinate is 0, and at -2 pi it is +1 again. So when you go to sketch the graph, it kind of looks like a tulip on both sides. We say that it has a fundamental period, of 2 pi. And why is that? Because between 0 and 2 pi, like if you were to pick this up, it repeats itself over here. It's just the same graph. So it's a periodic function, and between 0 and 2 pi, then it repeats itself. We would say that it has a domain that goes from negative infinity to infinity, or they might say all real numbers, and a range that goes from negative 1 to 1. They might say it goes from negative 1 to 1 and it's inclusive. And there's our graphs of sine and cosine.